I am Amy Pilling. I work producing these lasers for SciArt Santa Fe. We are a group of artists and scientists. Susan Latham and Dr. Andrea Poli are largely responsible for our group formation and our presence and our activities in association with Leonardo, the International Society for the Arts, Sciences, and Technology. So I want to thank Susan and Dr. Poli for making this happen. SciArt Santa Fe is a small nonprofit in Santa Fe. And again, we do mostly educational and art science integrated work. I would like to introduce Susan Latham. Susan has been working tirelessly to create opportunities for artists and scientists to get together and share ideas and talk. She is, I think, one of the more inspiring people I've met. She's an artist and she's incredibly enthusiastic about this mission. So Susan has a long history of education and curriculum development in the arts and sciences. She's really gotten quite a lot done in her life. So the more I've gotten to know Susan, the more impressed I am with her. So I'm going to keep it short, but if you get a chance, I'll put Susan's website up on chat too, and you can learn a little bit more about her. And Susan, I'm going to pass it on to you, but I think you're muted, so you're going to have to unmute.
There we go. Hello, everybody. It's my pleasure to introduce Gary tonight. Gary Lee Nelson is a classically trained composer. He founded and chaired the Technology and Music and Related Arts Department in the Conservatory of Music at Oberlin College, pronounced tomorrow. At the 1978 International Computer Music Conference, he was honored as a pioneer in the field. His travels have taken him to Asia, Australia, Europe, including Moscow. Nelson retired to Santa Fe in 2010 to be and to become. In the City Different, he has taught at the Santa Fe University for Art and Design and the New Mexico School for the Arts. Today, he will be talking about merging math and art. Take it away, Gary.
Thank you, Susan. Thanks for that nice introduction. Yeah, I will be talking about mathematical techniques that I've used to make my music and films and still art. I'm going to try to keep things up on the screen that you can watch while I'm talking. Keep the sound down on this one. In an interview, French composer and electronic music pioneer Edgar Varèse's work was characterized as experimental. He corrected the interview saying, "These are not experiments, these are results. The experiments are scattered over the floor of my studio." Tonight I'm going to use a format from early TV when a songwriter sat down at a piano and simply said, "And then I wrote." My time is limited, so I'm going to ask my studio manager, Allison. She's going to try to help me stay on track. I've asked her to read some portions of my script while I run the board. Here, take it away, Allison.
Pleased to meet you all.
And I'm going to turn that sound completely off. And here's some more from Allison describing some of my earliest work.
We are listening to Circuit, my very first electronic composition, 1964 to 1966, in the Netherlands at the Institute of Sonology of Utrecht University. Although they were beginning to use computers, they were not yet ready. All of my source sounds were created on tape with various lab hardware, oscillators, and filters. Many of the sounds were recorded from unused radio bands that broadcast various colors of noise. Lots of tape splicing. The final mix was made with a bank of tape recorders playing at varying speeds into a stereo mix. It was a blend of the two major approaches to electronic music then current, the French music concrète of Pierre Schaeffer, and the German elektronische Musik of Karl-Heinz Stockhausen. Sonology had devotees of both schools. I was chastised for not taking sides, but then I was there only 1 day a week. By the way, Gary, what were you doing in Amsterdam?
And let me turn the page here. I'm going to talk about seedable random numbers. Those are the first computer techniques that I used. And again, Ali is going to describe it.
From the beginning, I wanted to automate complicated musical structure and texture. The solution seemed to be random numbers. On the computer, we call them pseudo-random because, in fact, they are the result of traveling through a giant circle that includes all possible numbers in a complicated pattern that deceives human perception. In addition, I wanted to duplicate my results when I found something I liked. This is done with a seed that tells the computer where to start on the circle. Once seeded, the sequence of events would be as complicated as I wished but repeatable by resetting the seed.
For this music, I'm getting the seed from my Yamaha keyboard. Each key triggers a different phrase. Here's middle C. And if I press it again, it repeats it exactly. Another technique I've been using is nonlinear dynamics using the logistic map. The popular term for this is chaos. It's similar to randomness, but its output is different. And let me kill this image. The output is different. And I'm on the wrong page here. There we are. I'm going to show you a little tutorial that I wrote to help my students understand this. Here's the graph of the chaos graph. I'm going to start with a little bit of music here. So this is just some music that's playing that from that graph. There's a conductor, and he's conducting here at 120, and a harp is playing every beat, 100% of them. And if I reduce that to 50, what I've done is reduce the horizontal density, the number of notes that are played within a certain period of time. And now here's a string orchestra, also playing 50% of the notes. And every note is held for 4 beats, so all of these are whole notes. And if I change them to eighth notes, reduce the vertical density, that's just how many notes are sounding at a certain time. And so these things two together are describing musical texture. Now let's hear some percussion. Now we'll talk about this graph. There's a slider along this graph. Its name is R. And the further you go to the right, the more complicated things get. And I'm in this area right now, or perhaps this area, where there are only 4 possible notes. And I'm going to move this R graph to the other end. Much more complicated. And to get back to the simple part, Listen to it carefully. There's repetition, but it's not always exact. There are different things that happen, and this is a very advantageous property of this particular process. So I think I'll close this up. Now I have a piece that I made with this. It's a piece for solo marimba, and it was composed for a student of mine, Deborah Moore. She played it on her Oberlin Junior recital. And maybe I'll turn that up a bit. Now notice the alternating patterns and the repeated notes. And this is at the simple end of the chaos, or at least the interesting part of it. And the form of this piece is simply sliding the R slider from beginning, from where it is now, to the most complex. And here's a bit from page 7. And we can see immediately that the notes are all over the place, very angular, almost no repetition. Now another topic is Markov chains. And in the early 20th century, there was a group of composers in Vienna. I call them the Triple A. It was Arnold Schoenberg, Alban Berg, and Anton Webern. And this is the tone row for Webern's Opus 7 piano variations. And if we look across, if I get my mouse up there, if we look across this is called the original form. It uses the notes of the 12-tone scale exactly once each, and they create it so that there are intervals in it that give it some character. And so here's what the original sounds like. And then if you play it backwards, now turn your attention over to the first column, and if I play that downward, I'm playing what's called the inversion. Now we'll look here, and this it goes up a step from C to C sharp, and here it goes C to B natural. So this is an inversion. And then the fourth form is to play up that column. And that is the retrograde inversion. Now let's hear a little bit of that played by Glenn Gould, I think, is playing this. It's very soft. And Webern is also known for his sparseness and his brevity. Some of his pieces are, I think there's one that's only 7 seconds long. Okay, let's go back to that graph. Whoops. There we go. A Markov chain this is kind of an example of a Markov chain. I've written a number of pieces with that, and I'm going to start one that's called Magic Square. And my version of it is not just 12 notes, but any number I want, and repeating so that it becomes kind of a melody. And I don't know if you noticed that those 4 different versions, they had a certain similarity to them. And so what I do with my Markov chain is I start anywhere, and I move in some direction, and then I reach a point and I flip a coin that's weighted against heads. But if it turns out to be heads, I get to turn in some direction, this way, that way, even diagonally. And that's what this piece is all about. Now, last Halloween, I was invited to a party where we were supposed to read a scary poem or story. So I choose to use this piece, and you'll recognize the story. Let me turn the page here, and we'll turn it up a bit. In the year 2525, if man is still alive, if woman can survive, they may find a world different then from now. different yet not knowing how. Now I'll skip a few verses. In the year 6565, no need for husbands, no need for wives. You'll pick your son and daughter too from the bottom of a long glass tube. And then to the end. Now it's been 10,000 years. Man has cried 1,000,000,000,000 tears. For what? He never knew. And now his reign is through. Yet in the dark eternal night, there's still the twinkling starry light, so very, very far away. And there, perhaps, it's yesterday. Another area that I've explored is fractals. Here's a clip from an NPR program where they interviewed me about fractals and fractal music.
Well, fractals in general involve mathematics. Almost all fractals can finally be represented as a series of numbers. And if you were to use those numbers to produce graphic images, you would get kind of digital paintings. If you interpret the numbers as musical elements, melody, harmony, rhythm, then the result would be called fractal music, or music derived from fractal mathematics. There's a real-life analogy to fractals that I think most people have experienced, or at least observed. Imagine you're sitting in a barber shop and you're looking at your image in a mirror. Of course, you see yourself, but you also see your reflection from the mirror on the opposite wall, and those reflections are moving back and forth out to infinity. So this is a simple process and a simple input. Your image is the input, the process are the reflecting mirrors, and the complex result is this pattern of images that goes off and shrinking in size until they kind of disappear from sight.
Now we've been hearing through this fractal mountains. I'll turn it up just a little bit. And this graphic is an explanation of how we're doing this. I start to make my mountain with two solid lines. So we have the ski lift up and the slalom down. You split it someplace in the center and pull it out. And now you've got 4 lines instead of 2, and there's the second subdivision and the third subdivision. And when we get to the 4th subdivision, it's time to make some music. So we now have a melodic contour through a phrase. And at each vertex, I take whatever number is there and make it a pitch, and then I stretch it out to make a duration. And now, we're still listening to fractal mountains. This piece is a microtonal with 96 tones per octave instead of the usual 12. And here's what it would sound like on the piano.
Gary, is it possible to turn it up a little bit?
Better? Can you still hear me?
Yes.
Good. Now notice it's incredibly out of tune. And one of the reasons that we probably find that objectionable is that we associate the piano sound with its tuning. And so we've taken it pretty far from the norm. Now let's go back to the electronic version. And in this, most people wouldn't think it's out of tune at all. It might not even occur to them because the instruments are unfamiliar and the combination makes, as I intended, a mellow composition. I've also been working with sonification, and Ali will tell us about that.
Sonification is the creation of non-speech audio for information analysis. For music, the numbers are translated into pitch, rhythm, volume, stereo position and timbre. Each pixel in a JPEG image has 6 numeric values. The XY position yield information for pitch and rhythm. I use the RGB values to place sound in a stereo space. Bright red pixels are on the right, green on the left, and yellow in the middle. Blue is introduced for quadraphonic projection. Brightness also determines loudness. To play the image, I scan from left to right like a piano roll.
And what we're looking at is the score. And here's the image that it came from. This is a wonderful image by Aaron Beelish. He's an art and music instructor at Lone Star College in Kingwood, Texas. We'll look at a few features of this. I don't know if he intended this to be a face, but it looks like a face to me. There's an eye and a nose, mouth, chin, and maybe there are two more noses. I'm not sure what's going on here. But this is a feature to keep in mind when we see the next thing, which is the sonification and the animation of this image. Again, using this as the score. And on the right, you can see animation that's similar to the image. And then this blue and green is part of those, I don't know what to call them. It looks a little bit like a claw. And it's sweeping up through here as it goes as well. Now this is typical of a number of things that I've done. I've done some still images. I call them evolutionary digital images, and I'm going to start a montage of those images. And I make them in families of 16, and to make them more easily experienced, I created slideshows for each family and composed soundtracks that complement the images. My first family was called Oiseau Mystique. And the soundtrack is made from nature sounds, birds chirping, water running, occasional woodpecker. And the image that started this is a simple outline of a bird, which you can see in several places. You can also see the wing. There's a very clear bird at the bottom. Teardrops is a memorial to the victims of the Charlie Hebdo massacre in Paris in 2015. The soundtrack is meant to portray a sense of wandering sadness. And then here's another one that's animated. Shadow Man. Shadow Man uses some photographs of me in my derby and cane taken in the evening lights of downtown Santa Fe.
Shadow Man comes on nights of the full moon.
We dropped some stills into Photoshop and created abstractions, sometimes including multiple
His
images.
appearance is unpredictable in time or place.
And I animated the abstractions in 2 layers.
He has no mission or intent.
And then I composed music and wrote dialogue to tell the story of this mystical character.
He is neither good nor evil. Neither god nor demon.
And by the way, this is Allison's grandfather that's doing the narrating.
Huh?
And moving on, another system that I've found useful and attractive is called Lindenmayer systems, or L systems. And I'm going to play just in the background here a little bit of the piece that I'll talk about in more detail in a second. I'm going to make that a little soft while I talk. Lindenmayer systems use characters and letters for drawing instructions. So the initiator, this equilateral triangle, F says draw a line of a certain length into a particular place. Plus means turn to the right. Minus means turn to the left. So the program to draw this equilateral triangle is F plus plus F plus plus F. And the turning angle is 60 degrees, so that's why we need two of those. Then we look at the generator. Shortly, it's going to replace the three lines of the equilateral triangle with F minus F plus plus F minus F. And when it does, we get the Star of David on the right. And this is also recursive. So we do it again, we get this, we get this, we get this. And this is the Koch snowflake. It's the classical example of Lindenmayer systems. Now let's look at the one I used to make this piece that we're hearing. Figure 5 is something called a space filling curve. I'm not going to talk about that much, and it's the Hilbert curve. Now this piece is called Gauss because in the beginning I thought it was the Gosper curve, but one of my mathematician friends said, no, it's Hilbert. Well, I kept the title because I can't have the piece called Hilb. Figure 6, I decided, one of the rules of the space filling curve is lines can't cross. Well, I violated that with an angle of about, a prime number near 100 degrees. And notice in the lower left-hand corner of this figure, the lines are longer than they are in the upper right hand. And then I unraveled that and got this graph that is actually the melodic contour of the piece. Now we can look at it in score. The Zeta violin is an electronic violin, or an acoustic violin with an electronic circuit that can be plugged into the computer, so the computer knows what notes are being played. There's a scale, and Mark Litwin is the violinist. He has a pedal. If he presses the pedal, the computer takes the note he's playing and works down through the scale, skipping notes to make a chord. Now it's very similar to what we would do with a traditional scale. We'd make a major chord by skipping notes, minor chord the same. Then he's got another pedal. When he presses that, we'll hear it in just a moment here. And there, that sound. That's actually a quotation from Fractal Mountains. Now let's take a trip to the Milky Way. Allison, tell us about this image.
The seed image for this film is from an article about what a new telescope has found. The Milky Way has a turbulent center with nearly 1,000 mysterious strands, inexplicably dangling in space. It's about the work of Professor Farhad Yousefzadeh at Northwestern Center for Interdisciplinary Exploration and Research in Astrophysics. The animation technique is the same as described earlier.
Now, I learned about this research just a couple of weeks ago. I scored the film with singing voices to symbolize the distance between us and the galaxies. We humans seem fascinated with the vastness of space, while our minuscule egos try to convince us that we really matter in the grand scheme of things. And this is also animated on 2 layers. Then a few days ago, I ran across a poem by a Finnish author, Zacharias Topelius. I've been moving in the direction of storytelling with my films. This poem seems to be a good companion for these images. I'll read a bit of it. All the lamps have been put out, and now the night is hushed and clear, and all the memories of vanished days return and reappear. And tender legends flit about like gleams amid the blue, until with sad and wondrous joy the heart remembers too. The limpid stars look downward in the winter midnight's glow, with blissful smile as if no death were known on earth below. Can you discern their muffled speech? I'll tell you, if I may, a tale the stars once told to me about the Milky Way. This film is about 7 minutes long, and there are about 10 more verses like that. And the title is going to be from that last line, a tale the stars once told to me about the Milky Way. Another interesting algorithm is called flocking. Let's look on the internet for some examples of this. And here it is in nature. This is not my music, by the way. And these lovely fluid forms are made just by each bird having a certain set of behaviors that keeps them close to their neighbors. And the mathematical simulation looks like this. We joke that the person that came up with this algorithm was probably born in Brooklyn because he called it Boyd's.
The flocking algorithm is a mathematical model of the movement of flocks of birds, herds of mammals and schools of fish. It imitates the rules that govern the relationships between members of the group. I broke most of the rules in creating my Dance of the Planets.
In my film Progeny, 9 planets roam the insides of another giant planet. I gave them a set of behaviors. Near the end, they gather in a 3x3 formation before merging and fading away.
The geography is created by wrapping the globes with the circular paintings of Ohio artist Christine Gorbach. They are mostly black and white with bits of yellow and red. White makes continents, black makes oceans, and the colors become occasional flashes of lightning. The oceans are transparent. There are numbers in the coordinates and rotations that are used to make the music.
Now we move on to something called granular synthesis. Granular synthesis is the sonic equivalent of pointillism in painting. This music that we're hearing is made from small particles of sound. It's an early piece of mine called Particulation. I'm using granular synthesis in a project called The Dying of the Light. It's based on a familiar poem by Dylan Thomas.
Old age.
I'm going to turn this down a little bit. I'm also using granular for a dramatic effect where Dylan's voice wanders in and out of intelligibility. There's a slider where I can control the sonic equivalent of focus. The granulator breaks Dylan's speech into small particles that can be scattered at various distances from the words as he speaks them. And the closer the grains come back to home, the clearer the speech. And yet another process. Start a video here. And turn the audio up on this one. Cross composition was the name I gave to this process before a mathematician friend told me that what I'm actually doing is called convolution. Convolution is an operation where two functions are joined to produce a third that expresses how the shapes of one modifies the shapes of the other. In 2002, I made a film called Death and Transfiguration that was inspired by the tone poem of Richard Strauss. A great tuba part, by the way. I superimposed Strauss's pitches, melodies, and harmonies on a fractal rhythms and textures with an electronic orchestra of my own design. The animation was made with black and white photos that I took of things dead in nature. In architectural terms, the fractal provides the beams and the struts, while the Strauss pitches are responsible for the interior decorations. Now let's visit a concert hall in Vienna. This is where Strauss celebrates the climactic moment with a glorious, bittersweet minor chord of poetry suspension. And here's that moment in my film. At the climactic point, I freeze the frame on some crocuses newly blossomed to symbolize the moment of transfiguration. There it is. Then after a moment of hope, the music turns pensive, with the thought that life may not be truly a circle. And here's another one of my slideshows. This one's called Los Manos. And the seed image is a pair of praying hands. Spanish flavor. I scored it with some Cuban percussion. Then last week I made another example of musical convolution that I called Gustav in Habana. The surface is Mars from Gustav Holst's suite, The Planets, played at quadruple speed with the notes assigned to another band of virtual Cubans. Here is Gustav in Habana. Superhuman drummers. The surface is Mars from Gustav Holst's suite and The Planets, and it's played at quadruple speed. And here's the ending. Again, this is called convolution. It's the combining of two things to make a third thing. I've referred several times to my early ambition to spend my life as an orchestral tuba player. Let me get ready for this to go here. The core of that desire never really went away. In the mid-1980s, I returned to live performance with something called the MIDI horn. This is from a PBS program about new instruments, which of course they called experimental instruments. The piece is called Quintessence. I use modest mathematics for this one. I did everything I could think of with the numbers 1 through 5. Now we'll continue this piece while I talk about the MIDI horn. Now, I ignore the text. I'll just talk about the figures. The front of the horn has 8 keys. The top 4 are the same fingerings as a 4-valve tuba. The next 3 are the fingerings of a trumpet, but instead of dropping semitones, they drop octaves, so the instrument has a 8-octave range. The little key down here is like a shift key with which I can use all 7 keys to pick an instrument from the MIDI set of instruments. Here's the back. It has 2 joysticks, one for each thumb. And besides those are buttons that can be reached by the thumbs. And the buttons are highly programmable. There's one piece that I play a solo kind of thing, and then I hit that button when I want the accompaniment to join in. I'll keep that playing for a little while. I composed a 90-minute program of pieces for myself and took them on tour for more than 2 decades. The music was weird, but the concerts were well received. Here's a piece called Refractions. This was commissioned by the Prism Saxophone Quartet, and they played it on some Yamaha WX7 electronic wind instruments that came on the market about 3 years after the MIDI horn, which was never on the market, never will be. And encores weren't uncommon. Here's one that I like to play. Of course, it's Saint-Saëns' The Swan from the Carnival of the Animals. I added this video, it's just kind of silly. Swans are not very friendly. I was attacked by one in a parking lot next to a lake in Michigan. And this one is pretty protective about his pond. He doesn't want any Canada geese in it. And here's a piece I'll start. This is a piece by Thomas Morley from 1585. It's from a book of his called A Plain and Easy Introduction to the Art and Craft of Music. And he wrote it to demonstrate where you could go with prolations, something that he called that we would now call mixed meters and subdivisions of beats. And throughout this, I'm just playing this tune that you hear on the top. I just play it over and over while my two friends accompanying just get crazier and crazier. Here we are toward the end of the piece. And I'm playing on a trumpet now. And now a different instrument. Now we're going to return to outer space. Allie, tell us a little bit about the history of this.
In 2014, I performed Wanderings, Musings about Time and Space, at Currents, an international festival of new media that takes place in Santa Fe each summer. Both audio and video were created from the pixels in photographs from the Hubble telescope. This is the Red Skull. The images are treated as a kind of piano roll where the positions and colors of the pixels are mapped into musical parameters. There are 20 videos, each with its own galaxy and a duration of 1 minute. Here is the animation The Red Skull with soundtrack.
And the soundtrack is indeed there. The Inner Worlds of Outer Space is a film I made recently with the materials from 2014. I plan to use it in live performance while I read from the Wandering script. It explores time and space, eternity and infinity, with jokes. The monologue opens this way. I was trying to daydream, but my mind kept wandering. It's been so long since I did anything that mattered. I want to be original. I want to be new. But few human thoughts are unique. Only true geniuses create from scratch. More often we just notice what others have done and wonder how we might turn their efforts to our own needs or purposes. We just watch what passes by and act out of curiosity, necessity, or whimsy. Ultimately, everything we do is derivative. Maybe I should just write a nice little song.
Songs have been on my mind. Nothing fancy. Let's take it for us. Maybe you'll find a place in your mind. The things we know, we know, we know. The things we know, we don't know. Some things we know, we know, we know. The things we know, we won't know. Knowing as it is well known, what a long quest for man. For what we know, we cannot show. We do the best we can.
I stole that from Donald Rumsfeld. If you were born since 1970, you know
And
why.
thus we think, we thought, and thus we thought of laughter. So thus we thought, before, and thus we thought of laughter. Thinking thoughts is what we do, and thoughts we think won't think of. And what we think is true to life gives us a finger. have been forgotten. Some dreams we dream have dreamt ourselves, dreams we have forgotten. Dreams flow throughout our life, and life flows through our dreams. But nothing here is ever clear, and never what is